All right, how's it going, everybody? I'm sure you just recently watched my first little quick intro video. Now it's time to start in on some physics. We're actually going to jump into chapter 21 and 22, which is on thermal energy. We might hit some concepts that are in chapter 23. I'm actually very confident that we can handle this in this distance video online format. I think you guys will have been pre-exposed to this material, especially the stuff we're going to talk about today. You can see energy accounts are going on today, and then some thermal energy terminologies. This one is probably going to be pretty quick. I believe we may have mentioned some of this earlier this year, at least energy accounts back around chapter 8, but I do feel it's important for us to review it. Some of this type of stuff, heating, thermal energy, temperature, thermal equilibrium, that type of stuff we've probably covered in a chemistry class. But hey, it's information, it's introductory. This video will hopefully be a few minutes shorter. If you'll forgive the crazy movement of my eyes, I am sometimes looking down at the screen or looking down at a book, and I'm going to be popping in and out so that you can see some stuff on the screen. I don't think everything will be straight up Mr. Hicks talking head. I'm going to try and get some demonstrations, and we'll have to see how good the video goes with the demonstrations. I might end up referencing a demonstration and then recording the demonstration in a different manner and posting that. So let's just roll with the punches and go with it. I'll try to keep all the videos and things labeled and organized in the LMS. So you might be wondering, what about the Castle stuff? We were in the middle of a packet. We'll get to it. I'm actually considering maybe taking a look at the end of the packet and demoing a few things for you so you can finish that and, send you the homework and see how you do on the homework. And we'll just roll with it. My point is not to slaughter you guys on the grades here as we get moving. So let's jump into it. We're talking about chapter 21, thermal energy, and I want to talk about the first thing is the concept of energy accounts. We've hit this before, and I think it's an important concept for us to know. In our world, energy is a concept that is huge. Everybody uses energy. And we need it. Like, if we didn't have energy, we wouldn't be doing this online distance education thing because we wouldn't have electricity to run our computers and run the World Wide Web. We wouldn't have the ability to get from place to place. It's just energy is all around us. It's a topic that's always going to be out there, and it's something that more than likely some of you could have some significant impact on as you move forward into a career. So energy is important for us to understand. And one thing that is typically done in this world, we talk about kinds and types of energy. I don't like to use those terminologies, even though they're very common, because it kind of separates energy from other energies, when actually all energy is the ability to do work. And electrical energy just has a specific application that it's very good at doing, but you can convert it into another energy account that is usable. For example, the electrical energy account is really great for running our lights and charging batteries and running electronic equipment that you guys are using. But you can use electrical energy to toast food, like a toaster. There's electrical resistant strips that are in the toaster that glow orange and essentially turn electrical energy into a thermal energy account and toast the bread. Now, that's not the best way to get thermal energy, right? Honestly, the best way to get thermal energy is to burn something, not run electricity through a filament and heat it up red hot, but you can do it, right? So I'd like to talk about energy accounts because you can actually convert one energy account into another. Very much like money. We've had this discussion before. Money is money is money. It buys stuff, but it can go into different accounts. It can go into your checking account. Boom, you can have access to that through a check, through a bank card right away. Go out and buy your groceries, right? If you're looking for toilet paper, my wife said, the people that shop at Aldi's are not crazy hoarders. That's where she got ours. And I'm really not trying to make light of this scenario. Please understand My father is a paramedic and is working in the medical community in Pennsylvania. So when I talked to him today, I said, be safe, because I'm concerned. He's 65, he's in the age range, but he's out there trying to save lives. So I'm really not making jokes. Anyways, back to money accounts. Your checking account, easy access money. Savings account, it's still got money. It can still buy stuff, but you put it there for long-term savings to buy something later, right? Retirement account, it's still money. You put it in there, but it's a savings account for long times down the road. So it still does the same thing, but you can convert money from one account, place money in one account or the other and move it from one account to the other, just like you can do the same thing with energy accounts. You can take electrical energy and move it to a thermal energy account. You can actually use thermal energy and mechanical energy to run a generator to make electrical energy to run the grid. So that's the concept of accounts. Energy is energy is energy. It can be converted from one account to another to be used in a different way if needed. Now, one thing to keep in mind, and I think this basically heads more towards chapter 23 or chapter 24, there's a basic thermal law that says energy moves from high to low. And so, like, if you want to, convert energy from one place to another, that typically is going against the natural flow, the natural movement of energy. And so what that usually requires is it usually requires a little bit of loss or sacrifice. And that's what happens when you move energy from one account to another. There's typically some energy loss, some energy that is wasted, not used effectively. But that's pretty much every scenario. Anytime we're doing something, nothing is 100% efficient. We've talked about that before, right? So let's keep in mind, we're talking about energy accounts as in money accounts. It's all money, it's all energy, it all can do the same thing. There are some applications for these energy accounts that are better. And so we're moving into the thermal energy account in this chapter, and we're going to see effective uses for this. Now, I am going to try and keep this on a physics level instead of going on to the nitty-gritty chemistry level like we did before. So let's just keep that in mind. We're thinking physics here. We're not necessarily thinking chemistry. Physics and engineering is where I'm going to try and go. So in the next couple minutes, I want to try and hit some of these terminologies. They should be pretty much review for you. Because we've probably hit them before, and you can also read them in your book. So let's start off with the concept of heat. Now you can see I actually put in parentheses ing, because many times people use the word heat to reference energy, but really heat is the process, right? When you walk or you're walking, ing means you're moving, you're doing something. Heat really needs to be heating, right? Heating is the process of taking thermal energy and moving it from one place to another. So on a cold day, you go stand next to a fire and it is heating you. The thermal energy from the fire is being absorbed by your body and heating you, right? That's the concept. Heating is a process of moving thermal energy from one location to another, right? Thermal energy is the actual energy that's in the molecules. Right? So if you have something that is hot and it has a high amount of thermal energy, right? That object has molecules that are moving a lot and they possess that energy. Right? Now, temperature. This should be pretty simple. You've probably had your temperature taken. What it's doing is temperature is telling you what the average amount of thermal energy is, right? In a sample, in a location, in something. So temperature is the average amount of thermal energy that an object has. When you take the temperature of the air, right? I've got a thermometer here. It just turned off. Let me turn it back on. I think you'll be able to read the dial if I get it close enough. Right, there we go, 20.4 degrees Celsius. That's reading the temperature of the air. We'll take a second. This electronic probe is actually just touching the air that's right around the probe. It's not touching the air that's all the way in the back of the lab or all the way in the front of the lab classroom. It's just taking the average of what's hitting it. There could technically be some hotter air up there, like if there was a fire burning or something like that, right? That would be higher temperature, right? There could be, a cold drink over here, right? Well, this is colder, right? What you've got going on is, sorry, my screen went weird on me for a second there. What you've got going on is it's taking an average temperature, right? It's average of all the molecules that it's running into, and so it's just a basis for us to understand what is the general area like. Now, thermal equilibrium. This is important because when we're talking about thermal energy accounts, thermal energy is always moving from one place to another. It's moving from high to low. And we're going to get that when we get into the next chapter, chapter 22, because that's all about thermal energy movement, conduction, convection, radiation. That's the process of heating. Well, as things are heating, transferring thermal energy from one place to another, they eventually come to thermal equilibrium. That means when two objects are in the same place and thermal energy is being transferred from one to the other, they will both essentially equal out. The hot object will become cooler, the cooler object will become warmer, and then they'll balance out at the same temperature. And so as they're balanced out at the same temperature, they have hit an equilibrium. So these are some important basic terms. I think you've heard them before. You probably get them. If you have any questions, let me know. I can answer them. But right now I'm going to stop the video, and I'm going to reset, and we're going to do a video about specific heat capacity. I'm trying to break these up into smaller chunks because they're easier to put on YouTube, and they don't buffer as much and have as many problems. All right, I'm going to step aside and just let the screen go for a second. So if you need to pause it so you don't want to see any stupid ads or anything, you can do that. Signing off.